So this is lesson 9.3, B as in boy, intermediate algebra. We're still plugging away with some of these examples on simplifying radicals, and we're on example number 8, and we have 4 over the square root of 3. Now remember from the last one I told you couldn't have a square root on the bottom, so you multiply the top and the bottom by the square root you're trying to get rid of. And that gives you 4 square root of 3 over, take the square root sign off, and you've got your answer. Alright, 2 square root of 3x over square root of 5y. Cannot have a radical on the bottom, so we multiply top and bottom by square root of 5y, and that gives me 2 square root of, look what happens here, I can multiply these, 15xy over 5y, and we're done. Alright, so when you're multiplying radicals, that's one thing that you can do. You can take everything inside of any radical and multiply, as long as it's like the square root of something times the square root. If this were a cubed root and this is a square root, you can't multiply those. Only if they're both square roots or both cubed roots or fourth roots or whatever. Alright, so that takes us to example number 10, and we have 7 over the cubed root of 4. Okay, so again, we cannot have a cubed or a radical in the bottom. Doesn't matter if it's a square root or a cubed root. Now, so cubed roots, it gets a little tricky, because what if we did this? The top doesn't look too bad, but the bottom is the cubed root of 16. Do we know what the cubed root of 16 is? Do we know 3 numbers multiplied together is going to give you 16? 4 times 4 is 16. 3 times 3 times 3 is 27. 2 times 2 times 2 is 8. So, no, we don't know any answer there, so that can't be the answer. Alright, so what we're trying to do is we're trying to find something to multiply this here, change that, so that when we multiply something here times this, we can take the cubed root of it. So let's try, and this is where it takes a little bit of thought, where you got to kind of think through here. What if we took this 4 and made it 2 squared? Okay, so if you remember when we did these before, let's put a square root one up here. 1 over the square root of 2. We did square root of 2 over square root of 2, because what we get here is the square root of 2 squared right here. So because there was a 2 here and a 2 here, everything went away except the 2. And that's what we're looking for. We're looking for something cubed in here so that it cancels with this cubed. So we have a 2 squared here. So what if we multiplied the top and bottom by the cubed root of 2 to the first? Now we have a 2 plus a 1 that would give me a cube. So now I've got 7 cubed root of 2 on top, and I have the cubed root of this times this, 2 cubed here. So now these all cancel, and I get 7 cubed root of 2 over 2. Alright, so what I'm looking for, just re-emphasize this again. I have a cubed root of 4. I need the number in here to be cubed. So what do I multiply it by in order to get it to be cubed? Well, I could write it as, maybe I could multiply it by the cubed root of 4 squared. So that when I multiply this times this, I get 4 cubed. And that'll be 16. So 7 cubed root of 16 over 4 times 4 is 16 times 4 is 64. Okay, so I end up getting that, which can be reduced because we've got a 16 here over a 64 there. But this upper part here that I did seems to be so much easier. So if you can change your bottom number to an exponent like this, do that first, then find out how many you have. We had 2 and I need to have 3. So I multiply top and bottom by this exact same thing but with an exponent of 1. And when I do that, these signs all go away and all we have is the 2 left. And the 7 is just stuck with the cubed root of 2 here, and we're done. So this here, it can be done, but it's just kind of a mess. So it's better to take whatever number is here, make it into, take the square root of it, or I'm sorry, make it into a number with an exponent like we did here, then go through the process rather than go through this mess. Alright, let's look at example 11. We have 12 x to the 5th y cubed over 5z, and that's under one radical sign. So what we're going to do is we're going to split them up, and let's move it over a little bit so I've got more room. Over. Okay. Now what I'm going to do is I can't reduce the 5, it's a prime number, but I can reduce that 12 to 2 squared times 3, because 12 is 2 times 2 times 3. So I always like to do that if I can, get it down into its prime factors, and like I say, the 5 is already a prime number, so you don't have to do anything there. And then my index is 2. So again, 2 goes into 2 one time, so I pull the 2 out, and I have a 1 up there. 2 goes into this one, none at all, so it's going to stay under the radical sign. 2 goes into 5 twice with 1 left over. 2 goes into 3 once with 1 left over. So let's go ahead and write that alphabetically. Okay, that's the top. And the bottom, can't do anything with. That's simplified as much as we can go. Alright, but we have a little bit of a problem here. Oh, golly, we have a big problem here. I took that 2 that I had right here and I made it into a z. That's not supposed to be the way it goes. That's supposed to be a 2, and we'll put that in the front. Sorry about that. So that is what I've got at this point, but I can't have this there. I can't have a radical in the denominator. So there's my answer. Let's go ahead and take 2x squared y square root of 3xy over 5z, multiply top and bottom by the square root of 5z, and that cancels out the sign there, the radical sign, so we just have a 5z on the bottom now. But what happens on top? Well, there's nothing to multiply this by over here. There's no number in front of the radical, so it's going to stay the way it is. But I can multiply these and get 15x, y, z. And at that point, I am done. Okay, that's it for 9.3b, and the next lesson we'll do some problems.